This video is about graph changes to a parent function given a shift and writing a new function rule based on a given shift of a parent function. So there are 5 types of transformations that can happen. If you have f of x plus k, that's going to move the graph up k units. If you have f of x minus k, that's going to move the graph down k units. The other movements that happen with our f of x, if you have f of x minus h in parentheses together, you are going to move your graph right because you're only going to pull out the h value. If you have f of x plus h, you are going to move the graph to the left because you're going to take out the opposite of h, so you're going to take out negative h, which gives you a movement to your left. And when you multiply by -1, you are going to reflect the graph over the x-axis. Remember that when you are reflecting, you want to count the number of spaces to the x-axis and then repeat it on the other side. So let's start by looking at some graphs and writing our function rule. So look at the graphs below. The original function, f of x, is dashed and the transformation is solid. What change is occurring? So the dashed line is my original function. I'm going to pick a point on each function, on my original and on my new function, the same point from each line. So in this case, I picked the maximum point for each function. I'm going to look at the change. So I notice that I went down from one function to the other, but I want to know how much I went down. So I'm going to count 1, 2, 3, 4, 5, 6, 7. So in this case, my change is down 7. So for my function rule, I have f of x, and then down 7, you would subtract 7 on the outside of the parentheses. In number 2, I have my original function that's located below the new function. So I'm going to pick a point from each one. So this time I'm just going to pick the first point on each graph. I notice it goes up, but I need to know by how much. So I'm going to count 1, 2, 3, 4, 5. So my change is up 5. So I would have f of x, close my parentheses, and then plus 5. In the next one, my original function is still the dotted line. I notice that the new graph is to the left of my original. So I'm going to pick 2 points one on each line. So I'm going to pick these top first points. I'm going to count how far did I move. So I moved 1, 2, 3, 4. So my change would be going left 4. So in my function rule, I have f parentheses of x. This time I want to include my number. Now because it's left 4, think about that as moving a -4 along the x-axis. So we have to flip our sign so this becomes x plus 4. So remember that left and right are going to have the opposite signs. In number 4, when I look at my original function, I'm going to pick 2 points, so I'm going to pick the top 2. I know that it's moved right, but I need to know how much, so I'm going to count 1, 2, 3, 4. This time I went right 4, so I have f of x minus 4. Because remember, if we look back at our function rules, if there's a negative, we just put the number in to move to the right, whereas for the left, I have to flip my sign. Number 5, I notice that all of my dots line up with each other. However, the shape is flipped. So whenever my shape is flipped, this is a reflection. And so when I have a reflection, my function rule, I need to multiply by -1. So -1 times f of x. Number 6, my original function, I notice that it's moved 2 times, 2 different movements this time. So first I'm going to pick 2 dots. I notice it went left 1 and up 1, 2, 3. So my changes are left 1 and up 3. So I would have f of x plus 1, and then outside the parentheses I would have plus 3 for the moving up. Now let's try going the other direction. So you're going to be given an original graph and a new function rule, and you have to move the new graph. So if I have g of x and I want to sketch g of x plus 5, this plus 5 is outside the parentheses, which means I moved up 5 units. So from each point, I'm going to count up 5 to make my new point. So from here, I'm going to go up 5, 1, 2, 3, 4, 5. Place my new dot. I'm going to do that from every point. I'm going to go up 5 from each point, and then I can connect my points to make my new function. Number 7, given the graph g of x, sketch the graph g of x plus 4. So remember, your parent function is g of x minus a number. So because it's plus a number, we're really pulling out a negative 4, which means that we are going to go left 4 from each spot. So from each dot, I'm going to count left 4 to make my new dots. And then once I found my new points, I'm going to connect those to make my new graph. Number 8, g of x, and we want to sketch the graph -1 times g of x. When you multiply by a -1, this is a reflection, which means that my graph is going to flip. So I want to find how far am I away from the x-axis and then go that many in the other direction. So this first point is 1, 2, 3, 4, 5, 6, 7 away. So I'm going to count 7 in the other direction. 1, 2, 3, 4, 5, 6, 7, and plot my new point. The next point is 3 away from the x-axis, so I go 3 up. This is 6 away from the x-axis, so I go 6 down. And this is 3 away from the x-axis, so I go 3 down. So your point should end up on the opposite side that it started on when you do a reflection. So 3 of my dots were in the top 2 quadrants, so they end up in the bottom 2. And my 1 point that was in the bottom quadrant now ends up in one of the top quadrants. And then I just connect my points to make my graph. Number 9, g of parentheses x minus 2. This means that I am moving right 2 because I'm just pulling the number out. So I'm going to count 2 to the right from each point. And then I can connect those to make my new graph. Number 12, you're given 2 movements in this now. So you have g of x minus 2 plus 4. So the minus 2 means that we are going to move right 2, and the plus 4 means we are going to move up 4. So for every dot, I need to count both movements now. Right 2 and up 4, right 2, up 4, and do that for the other 2 dots. And then I'm going to connect my dots to form my new function. Number 13, g of x plus 1 minus 6 means I'm going to move left 1 unit and down 6 from each dot. So left 1 and down 6. So left 1 and down 6. And then I can connect my points. Notice that when you move your graph, it should still have the same type of shape every time. In the last few problems, we're going to be looking at reflecting and translating a graph. Make sure that if you have a reflection in your graph, that you reflect the graph first and then you translate. So in number 14, the -1 means that we have a reflection, and the -2 means we are going to move right 2. So first I want to flip where the point should be across the x-axis, and then move that point right. This is 6 away from the x-axis, so I go down 6 and right 2. This is 3 away from the x-axis, so I go down 3 and right 2 again. And then I'm going to connect my points. Number 15, we have again a reflection because of the -1. And then because of the +5, that means we're going to move up 5 after we reflect. So looking at my first point, it's 5 away from the x-axis. So I'm going to go down 5 for my reflection. I'm going to go up 5 for my translation and place my new point. The next point is also 5 away from the x-axis. So I'm going to go up 5 in the other direction, and then up 5 more for my translation. The third dot is 1 away. So I'm going to go down 5, or down 1, I'm sorry, down 1. And I'm going to go up 5. I'm going to do the same thing for that other point. And I'm going to connect them to form my new graph. The last two, number 16, we have -1 times g of x minus 7. So I'm going to reflect first, and then I'm going to move down 7. So the first point is 7 away from the x-axis, so I go up 7 and then down 7 for my translation. Next point is 3 away, so I'm going to go down 3 and then down another 7. Next point is 6 away, so I'm going to go down 6 and then down another 7. We run out of room on the graph, so just try your best to estimate it. And then my last point, I'm going to go down 3 to the x-axis. So down 3 more, and then down 7 for my translation. And then I'm going to connect my dots. Last one. The -1 again means that I'm going to reflect. And then the +4 in parentheses means that we are going to move left 4. So from my first point, I need to go up 7 to the x-axis. So I go up 7 and then left 4. The second dot, I go down 3 below the axis and then over 4. Place a dot. My third point, I go up 2 to the x-axis, so up 2 more and left 4. The last point, because it's already on the x-axis, it doesn't move anywhere, so it stays on the x-axis, and I just move left 4, and then I connect my points.